I'm Ashley, and today I'll be talking to you guys about the 2008 FRQ and the first problem. So for this problem, they basically give you a graph of sine of pi x and x cubed minus 4x. And so now I'll be explaining parts A, B, C, and D. So on to part A, they want you to find the area of this region. So in order to find the area, you first need to find where the two graphs intersect. So looking at this graph, you can see that it intersects here and here, which is 0 and 2. So the values of the integral would be from 0 to 2. And because the graph of sine of pi x is above the graph of x cubed minus 4x, then you would do sine of pi x minus parentheses x cubed minus 4x, and the integral of that from 0 to 2. And so here on my calculator, I've already plugged in sine of pi x minus parentheses x cubed minus 4x onto the graph. So this is how you find the integral. So first you go to calc. So in order to go to calc, you press the second key in order to get the blue, and then you press trace. And then here you can see the integral sign. So you press 7. And so since you're going from 0 to 2, your lower limit will be 0. And then you press enter, and then your upper limit, which is 2. So now it basically covers the region and will tell you the area. And so now it says the area is 4, and so thus your answer is 4. And so for this problem, in order to get full points, it's out of 3 points. In order to get full points, you need the integral, so what's inside the integral. To be correct, you need the limit, so 0 and 2, and you also need the correct answer. Alright, so now let's move on to part B. Part B says the horizontal line y equals -2 splits the region R into 2 parts. Write but do not evaluate an integral expression for the area of the part of R that is below this horizontal line. So here I've already drawn y equals -2, and because they want you to find the area below this line, you're finding the area of this region. And because you only need to use this curve, which is x cubed minus 4x, you can basically ignore sine of pi x for now. And so in order to find the integral, you first need to find the intersection. So you set x cubed minus 4x equal to -2. And then when you bring the -2 to the other side, you get x cubed minus 4x plus 2 equals 0. So in order to find that intersection, you can use your calculator. Here I've already graphed this region, this curve. And so now in order to find the intersection, you go to calc and then you go to 0. And then, so in order to find the 0, they first ask you for left bound. So your 0 is like approximately here. So left bound you would go to the left and then press enter. And then they ask you for right bound. So go to the right of that point approximately, and then press enter again, and then press enter. And they give you one of their zeros, which is approximately 0.539, which I have written here. And so now we have to find the second intersection, because it intersects the x-axis twice. So you can go to calc again, go to 0, and then go to left bound. So this is on the left. It doesn't have to be extremely close, it can just be on the left of that point. And then go to right bound, press enter again, and then the second 0 is 1.675 and on. So in order to find the integral, you take the two intersection points, so this point to this point, and then because y equals -2 is above this curve, you do the integral of -2 minus x cubed minus 4x, like the quantity, and yeah, the integral of that. So that's basically how you find the area, and because they don't want you to evaluate it, you do not need to take the time of your exam to evaluate this integral. And so in order to get the 2 possible points for this section of the problem, you have to have first the limits, so these 2 points, and then you have to have the correct function in your integral. So now let's move on to part C. So part C says the region R is the base of a solid. For the solid, each cross-section perpendicular to the x-axis is a square. Find the volume of this solid. So in order to do this, we know that the area of a square is side squared, and then we can set s, or the side, equal to the function. But since we have 2 functions, we have to combine it into 1. So as I said before, since sine of pi x is above x cubed minus 4x, you can just do sine of pi x minus x cubed minus 4x in parentheses. So then we take the integral of that from the 2 intersection points, which are 0 and 2. So it's basically the integral from 0 to 2 of sine pi x minus parentheses x cubed minus 4x all squared. And so here I've already graphed the inside of this integral, like that function. And in order to find the area, again, you do calc, and then you go to the integral, so 7, and then your lower limit is 0, and your upper limit is 2. And so it will give you the area from 0 to 2, which is approximately 9.978. So in order to get the full 2 points of this problem, you have to have the integral, so the correct integral, and you also have to have the correct answer. So now on to part D. Part D says the region R models the surface of a small pond. At all points in R at a distance x from the y-axis, the depth of the water is given by h of x equals 3 minus x. So you have to find the volume of the water in the pond. So since we know that the volume of something is always the area of the base times the depth. So the area of the base basically is the area of this region, and we know that the depth is 3 minus x. So in order to find the volume, we have to do the integral from 0 to 2, because that's the intersections of the 2 functions that you were originally given, of 3 minus x times sine pi x minus parentheses x cubed minus 4x dx. So you get 3 minus x as the depth from here, and then you get this part of the function from finding the area of this, which we did in part A. So in order to find this, I already plugged this entire function into my calculator, and so now you just have to do calc and then go to 7 to do the integral, and your lower limit is 0, and then your upper limit is 2. And so now this will give you the area, the volume of the pond. So as you can see here, it is 8.3699. So the College Board will accept 8.369 or 8.370 as an answer. So both of them are okay. And so in order to get the 2 points that are possible for this part of the problem, you have to have both the integral, so this entire thing, and the answer. So for some additional help on similar problems, you can go to the AP Calculus AB 2010 EverQ, and specifically number 4, and then you can also go to the 2011 EverQ and go to number 3, or to help on the concepts in general, you can go to area between curves and solids with known cross sections, Khan Academy videos, which are extremely helpful. And thank you for watching. I hope this was helpful.